Okay, well, let's get started. I'm just going to do a quick introduction, then I'm going to hand it over to the smart guy. My name's John Koss, and I'm here to introduce Nauman. So about 2 years ago, I had this crazy idea that, with this advent of cloud computing and web-based analytics, we might be able to actually do something a little bit different in technology. So what I did was I started a company called Pondera. And we hired 3 types of people. We hired people that knew Google very, very well, and their cloud services and their analytics. We went out to government, and we hired some real experts in program areas like Medicaid and SNAP and WIC and insurance and some of these areas. Folks that were involved on the program side and also on audits and investigations side of the business that really knew the business well. And then we said, wow, it's time for us to go out and get some people that understand data scientists, fraud analytics, and that was Nauman, who came from a background of the banking industry, and he was an expert in credit fraud, banking fraud, and analytics in the U.S. and in emerging markets, and done work at companies like Experian in the past. And my idea was, okay, I'm going to throw these folks all in a bucket and let them talk and argue and fight and create things together, and hopefully some good things will come out of it. I think both things happened, right? They got together and they shared ideas about what's the best way, the new ways, given the technologies that we have and the experience that we have in these programs to approach new answers to some old problems. And that's what we've come to at Pondera. So Nauman's really going to talk about today the approach that we take and that other organizations can take to implementing analytics, which is actually written about in a book today. Not today, he didn't write about it, but we have some copies of it. And that we've really built our entire company around this approach to implementing analytics so that it's not just a technical approach to problems, but a real business integrated with technology approach. Nauman has an incredible talent for taking very complex issues and making them simple, which was important for dealing with folks like us. And by that, I mean me. And I think he's going to share some of that today. So I hope you enjoy it. By the way, this is supposed to be kind of fun. So if you have questions, please, we encourage you to ask questions. If no one asks questions, we'll probably ask you to ask questions. Nauman will get you on you as well, but this is supposed to be interactive. Okay, so thank you very much for coming. Nauman?
Okay, thank you, John. So basically, I'm sure that throughout the morning you have been hearing about big data, technology, terminology. So we're going to take a slightly different approach. We're going to try and simplify things a little better and kind of start on a lighter note. So basically, I'll start with let me see if I can get this to work. Okay, so we'll start on a lighter note. So sometime back, a traveler advisory group came up, they hired some data scientists, they sat down and they said, you know what, this has been happening a lot. They looked at some data, they did some predictive modeling, and they came up with this. They said that there's a high probability that every 10 millionth flight will have one of the pilots drunk. And as the output of this study came out, then all of a sudden there was like a crisis in the industry, and that translates into probably one flight every year. People started canceling their travel plans. So the airline executives got like really upset and said, well, what is this? We need to respond to this. So the airline executives went and hired their data scientists, and they said, you know what, we need to respond to this study that pilots are going to be drunk every 10 millionth flight. So the data scientists from the airline industry, they went to work, and then after a while they said, you know what, actually the calculations are correct. This is actually happening, but don't worry, we have an answer. There is hardly any probability that 2 pilots could be drunk on the flight, right? So we recommend that you encourage one of the pilots to consume alcohol before the flight. Now, the moral of the story is that the data scientists working for the travel and consumer advisory group or the data scientists working for the airline, I'm sure both were highly competent data scientists, had the credentials, had the education, had the background. The technology that they put to work to do this was also state-of-the-art. But what's the benefit? So my approach to analytics, big data, that has come up in the book, and have been teaching and implementing that across 3 continents. And what Pondera is kind of all built around is the reverse. What do you want to do? We focus on that first. Technology will come later. We'll keep on evolving, and you will catch up with it. We will show you how to start small and then slowly grow. When you're ready, you go and buy the big technology. So that will be the theme of the presentation, and that has been the theme of kind of my mission the last few years, to simplify analytics, make it easier to adopt, and provide an evolutionary path for everybody, organizations of all sizes, government or non-government, and take it up from there. So I'm not a data scientist, even though John introduces me like that. I'm really not. And I have no idea what this equation means. One of my analysts put it together, and he was very proud of it. And I said, what does it do? And he said, well, it provides credit risk profiling in India. And I said, okay, what do I do with it? And so my point is that that's not necessary. You will find analysts, you will find statisticians. There will be a lot of people who know how to do this stuff really well. So I'm just a data architect. All my life I've worked with data, trying to solve real problems with data. And then analytics comes along, and I love it. I use it to solve business problems, and my mission is to democratize it so that everybody can use it. Make it simple enough so that everybody can jump on it. And especially government, agriculture sector, and education. So these are the kind of 3 that I'm heavily focusing on in terms of teaching and researching, because they hardly ever have the funding, R&D money to go and do big data analytics type of projects. Yes, sir. So the question is, I fully hear you. So the question is that a lot of times government doesn't have the resources, who have the expertise to interpret this thing. And that is exactly what I'm going to challenge in the next 20 minutes or so. So I'll show you why you don't need it. You can do without it. Okay, so this is the company, Pondera. John talked about it a little bit. We're not going to spend a whole lot of time, but the reason why I'm putting it out there that I have written a book. There is a company, it's a startup. So our belief in this approach is real. It's not just theory, we're not just talking about it. We are actually putting our money where our mouth is. Now, let's define it. So this is the most important part, because this is the most challenging part. Everyone's going to define it differently. Good question will get you a signed copy of the book. So here's an incentive. So we are all familiar with, so this is what I define as an information continuum. This is like the evolution of using information for better and higher things over time. So what you deal with on a day in, day out basis is this. Basically, somebody's on the phone, and you quickly go into a system, and you look up their record, and you try to figure out how to serve them and take care of the business there. Also, you have sometimes lists printed out, hand it to your operational staff, and they go work on that list. And you have some kind of operational reporting going on a day in, day out basis. So this is regular day in any government or even in a private sector. A white-collar job is this these days, right? And so this is what we call present. This is happening now, whatever is happening during the day in the operation. Then what happens is over time, as these operations are taking place, you start to collect this information, and you move into more of a historic perspective of this data or this information, and you start to do some summary reporting over a few years, and then you start to kind of get some snapshotting that, hey, last year, this quarter we did this year, this quarter we're doing that, and you start to go into deeper dive into the data. Then you start to develop some metrics and KPIs on which your business operation, your day-to-day lives are managed and measured. And then there are some kind of analytical applications that come along that if this happens, then we need to quickly alert somebody to go react to this situation, stuff like that. You are all very familiar with this. So the present box, that's your operational systems. That's your day-to-day transaction systems. Your business process automation is in the present box. The historic box, is your data warehousing and business intelligence. And over the last 15 years or so, we are all very very familiar with this. We all have some kind of a reporting data mart or a data warehouse sitting there, which does this for you. Analytics is the future. So the definition is that any technology, any tool, any hardware, software, any consulting service that deals with the future can be qualified as analytics. If it's not, if they just representing the same past stuff in a new packaging or a new form, it's really not analytic. So our definition is that it's about prediction, it's about future, what can you do, what actions you need to take, whatever technology or service helps you towards that, that can qualify as an analytic service. And this definition has been around since statisticians and actuaries, they have been doing this for a long time. Wall Street has been doing this for a long time. They never confuse the issue of past versus future, and it's very clear in that space what this is. These days in the technology space, it's getting all kludgy. It's very difficult to draw a line who is really an analytics provider versus just a repackaging of the same information. So, and you will also hear a few terms. I'll just talk about that a little for a couple of minutes. There is descriptive analytics, there is predictive analytics, there is prescriptive analytics. There's all sorts of words going around. Don't worry about them. They will settle down. As the industry matures, they will start to agree on some common definitions, and over time they will evolve. Don't get caught up in that. Focused on the perspective that it has to deal with what should I do. So this is what you are doing right now. This is what you have done before. It kind of gives you a perspective. This is what you should be doing tomorrow, next month, next week, next quarter. Okay? So that's the first step in the definition. But then what is this? How do you do future? Well, here's a very simple example. So this is your historic data, and all it is that these people either bought the computer or they didn't buy the computer. Very simplistic example. So customers' age or age range, income brackets, whether they were students or not, and what kind of credit rating they had. So this is from historical data that you've looked at years and years of sales, and you came up with a data set that looks like this. Real simple. Then what you do is you run this through a data mining engine. No statistics involved, no formal training in mathematics or linear algebra or differential equations, none of that is required. You download a free copy of a data mining tool, and you play with it on your existing data. What it will do immediately, it'll use one of the techniques called the decision tree. They come pre-built with these type of techniques in the tool itself. You don't have to come up with it. You point it against that data, and it'll give you a pattern. On that historic data, it will look at the data, and it'll say, okay, so this is what you're trying to predict. So let me see what are the common elements here that make this prediction. And so it'll come up with this, and it'll say, okay, if age is less than 30 and it's a student, then yes, they buy the computer. So if you go to the actual data, less than 30 and student, let's find a record, less than 30 and student, they buy the computer. So the data mining software will find these patterns. You don't have to do anything. It'll give you exactly this output in a visual form, which looks like this. So it's not that you have to sift through equations or mountains of data to figure out what it did. The output would actually look like a tree. And then, so this is what we call a trained model. So now it's ready. It has learned from historical data who buys the computer and who doesn't buy the computer. Now you have a new customer walking in, and they are 27 years old, and they are not a student. Are they going to buy or not? No, because it's 27-year-old, so they're going to be here. They're not a student. They're not going to buy. So you're not going to spend time and resources of your sales staff, of your sales infrastructure on that customer, because the likelihood is that he's not going to buy. You're going to focus on customers coming in who are going to buy, and you're going to put your resources on that. Okay? So that's how what you do is you kind of take you define this as a predictive variable that, okay, this is what I'm trying to predict, and it's filled up for the historical data, so I know who has bought and not bought in the past. And then you run it through the decision tree algorithm, which, as I said, you can download it. It's no rocket science. Any technologist, it'll take probably 2 days to figure out how to run this thing. They are actually very intuitive and easy to use. And then once it has learned from that, that's the tree that we just showed. So it said, okay, I now have a model. I know who buys and I know who doesn't buy. Now when you have new people coming in, so one of them is greater than 40, has a medium income range, and is a student, and has an excellent credit rating, you ask this model, well, what's going to happen? Is he going to buy or not? And the model is going to tell you, because this time around you don't know what they're going to do, it's going to tell you that, yep, this is the input and this is the output, whether they're going to buy or not. So now you have some future information in terms of what you can do about it, where you're going to direct your resources. And that is why we differentiate between looking at reporting and historical data versus a technology that is giving you ability to take future actions. And that's all the time we're going to spend on defining analytics, because that's really what it is. It's nothing more than that. So currently what happens is that, so that was the simplicity part of it. Now let's move into the democratization part of it. Who's going to get to use analytics in their day-to-day jobs? Every line manager should be using analytics to improve their metric, improve their performance of their department or of their team. Today what happens is that usually there's a select group somewhere in the organization that have some money, they were able to work with a vendor, they brought in some technology, in a silo they have been working on analytics and maybe getting some good results out of it. And another, so these two examples are from a large bank, but this is what happens. Only small pockets of the organization that can afford it goes and does this. So that's not a scalable model. You will never, so they may have like a few very high-paying data scientists, they may have high-end technology, they may have spent like $8 to $10 million in getting whatever they were trying to do with it. In these departments here, they don't have $8 to $10 million to do this, so they will never get their shot at using analytics to improve their business operation. The other thing what you see here is typically, this is a typical picture. So the data scientist is your driver. That's your grand poobah. He's going to do everything for you. He's going to bring all this data from these operational systems. He's going to identify what is important. He's going to bring it down. He's going to create his own little island database, and he's going to work on that database. He's going to build statistical models, and then from the output of those models, he's going to try and influence some policy and process decisions that, hey, we can now forecast this, we can predict this, so maybe we should change our operational practices a little bit. That's a typical model that you will see. Now, involved in this activity is he has to come up with a problem statement. What are they trying to solve? What is the problem they're after? This person has to figure out what are the business processes around that problem, has to figure out what are the operational systems, how to get that data out, all of this. So this is not an easy undertaking, and these people are very hard to find and even harder to retain. So here's a sampling of what you need in these data scientists. So they have to have a graduate level degree in some kind of a data sciences, mathematics, or statistics. They have to have experience in building and deploying models, extensive domain knowledge in that problem area where they're applying their skills, advanced database knowledge, knowledge of some of these tools, advanced SQL knowledge, presentation skills, ability to business case, do project management. Where are you finding these guys? They don't exist. And here's and increasingly actually now these days, like, okay, you got to have Hadoop on your CV, on your resume. If you don't have Hadoop, you're not a data scientist. It doesn't even count. So I mean, this is unrealistic. So we might as well go ask them to repaint the Sistine Chapel, because if you find somebody like that, they probably will do a good job. So, and what I did was I spent quite a bit of time on Monster and Dice, the two big job boards, and I looked for data science job positions, and I said, what are they really asking for? And I kind of did a sampling of that, so I applied some of my data skills on the job boards, and I tried to figure out who are these people, who's hiring them, what they think they're hiring. And this is the sampling that I came up with. So, so you've done your undergraduate, and then they're kind of, sorry about that. So they've done their undergraduate, and now they're like, at least 20 additional years to do this, 5 years, 10 years, 15 years. So after your high school, you're going to be 70 when you're ready to be hired as a data scientist. So clearly, this model cannot work. And that is what everyone is talking about. Oh, you need to hire these data scientists. And there's a shortage of 1 million data scientists in the country. Yeah, we know. But you can't expect to create these people. You need to simplify the process. You need to break it down into smaller pieces and get more people to work on those specific pieces rather than getting one guy to do everything. Okay? So how do you increase the adoption of analytics? How do you actually go on with the challenge that you're faced with? So first of all, democratization means that if you look at an org chart, every box on that org chart should be able to employ analytics within their division, department, agency, within their area of responsibility. And everyone can. They do look at reports. It's not that they're oblivious to data to run their operation, but the reports are typically a month or 5 weeks, 10 weeks behind. So you need to get in front of the problem before you realize after the fact that it didn't work out. So the first thing you need to identify is, okay, what is the problem that you're solving? Everything has to be driven off of this. This is not an overwhelming task. Let me give you a very simple tip how to figure out these problems. All of you consume reports. Reports come out every week, every month. You look at those reports, and based on that, you kind of readjust your activities and respond to certain situations. On those reports, there are certain metrics. There are certain pieces of information that you drive your duties and ownership and responsibility against. You take that metric because after a month of operation, on the 3rd of the next month, you receive that metric, and at that point you realize whether you've hit the mark or you've missed it, or how well did you do last month, right? So you take that metric and you say, you know what, I'm going to try and predict this metric on the 23rd of the month, so I at least have 7 more days to do something about it if the prediction is like really horrible, that I'm going to miss my mark. And that's where you start. The moment you have that piece of information from a predictive model that, hey, you're going to miss your mark, there is something you can do about it in the remaining 7 days. And that's all there is to it. So that's where you start, and then once you get a better hang of it, you start to take on bigger, more ambitious projects. But this is the starting point. Stick to that metric that everybody understands, everybody lives by. That metric is produced by the data warehouse, so all the relevant data is probably already in there. All you do is download a data mining tool, run that data through it, play with it a little bit. Maximum of 4 weeks, 3 weeks, you will start to get output. So, and then finding entrepreneurial managers, so people who are not afraid to take on some more ambitious tasks and are kind of a little more aggressive and innovative in their approaches. And then, this is the most important part, the decision strategy. What do you do with this knowledge? So going back to the example we started with, if you ask the data scientist after they did their model and they realized that there is a low probability that 2 pilots would be drunk, well, it was a good insight. There was nothing wrong with their mathematics, but they had no clue what to do with that information. So you can't really leave it to them to figure out, even if on the 23rd of the month you know you're going to miss your mark by 10%, the data scientist or the technology team putting it together for you is not going to be able to tell you what to do about it. It's your job to figure out, well, okay, if this information does show up early, what am I going to do? I'm going to grab a couple of my super employees and ask them, hey, you know what? Looks like we're going to miss. You guys need to step up. You need to help out, see what other areas we can focus on to meet our mark. So this decision, how to use analytics models output, is really yours. And without that application, the technology, the science, the mathematics is all useless if you cannot put it to work. But you can only put it to work if it's simple and relevant enough to your job. So let's look at the success of data warehousing. So data warehousing now is commonplace. Everybody has it. Everybody knows what it is, what it does. But in the early 90s, when the concept emerged, there were these massive technology-driven 3-year-long projects to put this thing together. And for 2 years, 3 years, so many people working on it, bringing all this data in, and there was no output. So there were a lot of failures, and I certainly see that happening in the big data space, where you're spending a lot of money for getting results, and 1 year, 2 year, 3 year, you're not going to get results, and you're going to get frustrated, and the project is going to get canned. So what data warehousing did, reacting to that situation, that these monolithic, huge systems, nobody wants to build them anymore, they said, okay, we'll simplify it. So the concept of the data warehouse was really simple. You have this data sitting around all over the place, bring it together. You did not need any technology or knowledge or degree in computer science to figure that out. As a manager, you understood what kind of pain that creates when your information is spread out. Quick results, so you started creating these data marts within a 3-month to 5-month cycle, and you started producing output, and all of a sudden people could see the value of them. Even though they were simple enough, they were there. The quick results means a lot for the project's continuous funding. Evangelize, so now this manager is getting this report, he's happy with it, he got this done in 3 months, and now he's able to improve his operation. He's gonna show it around. Hey, I get this every week, and I do that with it. So now other managers are gonna start to listen, they're gonna start to pay attention, and that is exactly what happened to the proliferation of data warehousing across every single agency and corporation. Then data management, so you gotta have your foundation correct. If you were bringing in crappy data and delivering to the manager, no matter how fast you were doing it, it was not gonna work. So you gotta have skill and ability on the focus on the right piece of technology that you're gonna invest in. And then of course the holistic view, because at any given time, data warehouse was always kind of look at things from a data perspective, which means they will always look at a holistic view, not a siloed view. So this allowed these 5 things that contributed for data warehousing to be accepted across all organizations, public or private, any size. Everybody has some kind of a data mart or a data warehouse running with some reporting off. And that's a similar lesson that I'm applying to analytics, that unless you do these things, simplify it first, quick results like that metric, you just predict that metric. That's it. You don't need to revolutionize the world or boil the ocean or anything like that. Just stay simple. And then evangelize, show the value of that you can react a week in advance before that metric comes out. You can change your operational strategies and meet your mark, and go with that. Now, the data management piece is already done in the data warehouse, so you don't need to restart that activity under your big data or under your analytics piece. You gotta reuse what you've already put together. So data warehouse as a foundation. So here is an example. Here is what you have. Typically, you have your operational data sources, you've got a data warehouse, some departmental data marts, and then you've got your analytical applications, reporting, dashboard, some visualization, these things going on. The consumption of this is all across the organization. So the org chart, everybody uses some kind of report, some kind of information coming out of there. So everyone is committed to the success of this. Same thing has to happen on the analytics side. If you're not going to do that, it's going to remain a silo, and not everyone's going to benefit from it apart from that small group of people. So same thing is over there. You need your operational systems, and you need your, so because we're democratizing it, so then every single manager needs to make use of it. So then you take the existing data warehouse and build specialized marts. And then you put data mining on it, and you do some scoring and modeling on it, and then your decision strategies. Again, decision strategy is the key. What you're going to do with this information if it does come in a little early. So that is new. It never existed in the data warehousing world, but the other pieces, this is there, this is there, this is slightly adjusted model of the same thing. So someone, if you have a staff that knows how to do this, they can very quickly figure out how to do this. And no big deal over there. This, I'm telling you, download a tool or buy a product, data mining tool. A lot of the database systems come prepackaged with some of these libraries. Download it, play with it, it'll work. sure. They are actually very good. And nowhere did I mention statistics, a master's or a doctorate in statistics, linear algebra, regression modeling. None of that is needed. You start simple and you keep it small, and then this is where the focus is. All along, you should assume that this will get done. I want to figure out what I'm going to do with this information if it does come in a little early. Is this making sense, or is this totally kind of overwhelming or underwhelming or ridiculously simple, not good enough to sit here or anything like that? Any feedback so far? Very good, okay. So one more thing you need to consider here is very important, and that's the audit and control piece. And because you're making these decisions on information that is coming before its time, so you are like predicting that this is what's going to happen and you're reacting to it. What if the information is incorrect? What if the model somebody has made a mistake? What if the model is not giving you the correct information that you needed? So you gotta track what did you do with that information. So on a monthly basis, taking our metric example, on every month, 23rd of the month, you run this predictive model and it predicts your number. You need to retain and save that, because after the 30th, on the 3rd of the next month, you will get the actual number. And you will compare that to the predicted number, and you're going to say, okay, how far off was I? If you were like really far off, then you know that I cannot rely on this number yet. Someone needs to go back and tune it and continue to play with it until it gives me the number that I need. And you can do this in retrospect as well. So if you have 2 years of history sitting with you in your data warehouse, you can take 18 months to build the predictive model, and then you can test it on the 6 months. And then see how well it is actually measuring, because the actual numbers of those 6 months are already with you. So, but the audit control is very, very important. So let me tell you something about the 2008 mortgage crisis. The analytics kept telling you these are subprime customers. They are going to default. They are not going to be able to afford these mortgages. What did we do? The decision strategy failed us. They kept lending to them. And not the data mining, not the modeling, not the scoring, none of this failed. Everything was fine. They kept telling them this is going to blow. And the decision strategy was like, it's real estate. It doesn't go anywhere. So we'll keep investing, and it will ignore what the model is telling you. So it's a classic example, like our pilot example, that this can make or break your analytics strategy. And that's where the focus should be, not underneath. That's easy. That'll keep data mining tools, new tools will keep on coming, free new tools will keep on coming, new database technology will keep on coming. That's fine. It's going to move into the cloud. If it's not on premise, it's going to get cheaper and cheaper and cheaper. That's not the focus. The focus is how you want to put it to work. So here's like a high-level development process that you can follow to adopt analytics in your organization or in your department. So you take your existing reports, you take your existing metric, and you start to predict the metric, okay? So the data acquisition that you need for this data mining activity to predict this, just outsource that to the data warehouse teams. Even if that data is not in the warehouse that you think is important, ask them to go get it. They have hooks into all parts of the organization, into all systems anyway. They can get it done far quicker than if you were to hire a data scientist, a consultant who's sitting there and trying to navigate his way around the organization. How do I get that data? It's much easier if you outsource that to the existing data warehouse team. Similarly, the cleansing, the sampling, the candidate variables, data aggregation, all of that, the data warehousing teams are very good at it. You rely on them, leverage them to do this for you. Don't reinvent the wheel. The model building is the only new piece that you are introducing, the analytics model, the data mining model. So I'm going to talk more about this statistics versus data mining in a second. And treat this model building as a black box. This data mining software, don't try to open up its cover and try to figure out what is it doing underneath. Just trust that it's a black box and it does what it does, because you're going to benchmark its output against your previous results anyway. If the results are in line, then this black box is fine. If the results are not in line, then this black box has a problem and you may want to get another one. but you don't need to understand what's going on underneath. People with 3 PhDs and 20 years of working with linear algebra and differential equations, let them worry about what goes into that black box. So you get the data mining software, and you make sure you emphasize the validation, that whatever it's spitting out from a historical perspective, that is what you have been receiving. So essentially what I'm saying is that this is what is needed to be successful with analytics. And traditionally, this one guy is responsible for all of this. So what you're doing is essentially breaking this responsibility into multiple chunks and handing those out to different teams or different individuals who are very good at their focused area of responsibility. So you don't have to create this superhuman, because you won't be, even if you can create him, you won't be able to retain him. He's going to go start repainting the Sistine Chapel. So quick deployment, decision strategy design, this is very, very important. Focus on that. So once you've validated that, yep, this thing works, then you can deploy it, meaning on a regular basis, every 23rd of the month, this thing will fire off and give you an output. That is what deployment means. It is really that simple. And then you focus on the decision strategy design. Okay, what am I going to do with it? So here is the challenge. So let's say you are predicting the number of cases closed in a month, right? Let's say that was the metric that you are measured on. So on the 23rd of the month, you run this thing and it says, well, you're going to close about 200 in this month. And you were expected to close 240, right? That number is not absolute. There is a degree of probability associated with that number 200. It's going to tell you that there is a 80% probability you're going to hit 200. Well, if it says 80%, you may want to take its word for it and pay attention to it. If it says there's a 10% probability you're going to hit 200, then you can ignore it. Nah, it's not correct, or it's not worthy of my time and attention because the probability is too low. So this is not absolute, because you're going into the future, there's going to be some gray area, and you will have to use your judgment, your years of experience into that thing, to take that output with a grain of salt. You cannot blindly trust that output. So there are decision points, what you're going to do, how you're going to alter your processes and your activities now that you have this initial additional information. You're going to look at the financial impact of that, favorable, unfavorable, additional cost, additional value. And then this is very, very powerful, what we call the champion challenger strategies. So let me give you we're doing okay on time, right? We're doing okay on time, okay. So let me give you an example here. So about 12, 15 years back, we were working in a credit card fraud situation at one of the large banks, and one of the correlations in the data that we found was that if you have a $1 transaction on your credit card, the next transaction is a stolen credit card or a fraudulent transaction. So the data went in and figured this out. Now the subject matter experts in the credit card business, they kind of sat down with their heads together. So what does that mean? Why is there this $1 transaction that consistently stands out before a fraudulent transaction? And what they found was, or they reasoned, they kind of figured it out, that the moment somebody steals a credit card or comes across a credit card, they want to know if it's been blocked or it has been reported. So they go to a gas station, they quickly swipe it. They really don't need gas. They just want to see if it's working. And they really don't want to stand there filling up their tank and lose valuable time. They want to see it works. They will rush to the nearest store and they're going to start spending that. So this insight came from the technology. Now, what do you do with this information? So, room full of analysts and subject matter experts, they say, well, you know what? Let's block the credit card as soon as there is a $1 transaction. That was one idea. Everybody debated. Nobody really knew what kind of an impact it would have, adverse or favorable. Another idea came along that, you know what? Let the second transaction, the next transaction go through, and block it at the time of transaction, to make a call. So sometimes there is a suspicious transaction, the merchant gets a call from the bank that, hey, can we talk to the customer who's trying to make this purchase? And they said, the moment we do that, we can dispatch a 911 call, and we can send a squad car over there, and we can try to arrest this guy who has stolen a credit card. So that was another approach that they could employ. And then there was another banking fraud specialist in the room. He said, you know what? No, I want to let that transaction go through. I want to know what that merchant is doing. Why isn't he reviewing the ID or is checking the signature on the card? Why is he letting it go through? So his opinion was, let's see if we see a pattern of these merchants who are colluding with credit card stealing rings and working in conjunction with them. Let's see if we can spot them. So put them on a watch list, put them on a radar, but let the transactions go through. So now all of these three are very strong arguments, and people presenting these arguments have strong reasons for it. What are you going to do? So that is where we kind of focus on this concept called champion challenger strategies. You pick one, and you say, okay, 80% of the cases, we will use this one. 20% of the cases, we'll use the other. And 3 to 6 months later, you kind of measure their impact. If their bottom line impact from that 20% sampling is good enough, maybe it was a stronger strategy and should have moved that into the front. And that's how you can constantly come up with new ideas. What can I do? Do I retrain my staff? Do I hire more people towards the end of the month to meet my quota? Do I change the way calls are routed? Do I change the way people come in for work? I mean, there are so many ideas that you can implement within your organization to make use of this early knowledge. But which one is going to have the best benefit for a sustained amount of time? You will have to play along with it. You will have to try it, give it a shot, measure it, and then see whether it is having the desired results or not. So extremely important, the culture of constant innovation and improvement and optimization. So we use Google very heavily in our business in Pondera for our fraud detection activity. All the principles that we've so far talked about are absolutely embedded down to their core into our operation. But we use Google, here is why. So I don't have a statistics background. I don't even have a data mining background. People from computer science and artificial intelligence degrees, they are the ones who have data mining backgrounds. And statistics, of course, is kind of coming from econometric or the statistics background. So if you go to the Wall Street, if you go to the financial sector, 99.99% everybody uses statistics. That's what they know, that's what they've learned, that's what they've been using for a good 40, 50 years. So that's the dominant tool for analytics. If you drive a couple of hours from here down to the Bay Area, everyone is on data mining. Because companies like Google and LinkedIn and Facebook and Yahoo, they immediately realize that the amount of activity that they want to perform with data, creating this super statistician data scientist is a bottleneck. They need like 1,000 of them in every single team deployed all across their organization. They cannot produce or create these type of data scientists so fast. So they said, you know what, we're going to look at alternate ways. And data mining was sitting there for them to make use of that. So data mining works. The evidence is Silicon Valley. It's not that you're going to be trying something that no one has done and you're not sure whether it's going to deliver results or not. They do it day in, day out basis. And there is some conforming there is like some discussion going on about this, which one is superior, which one to use where, and both have strong proponents who don't want to lose their position. But data mining is simple. Statistics is not. Then we model in the cloud. So here's another important thing. Remember the model that I showed you, age? It showed you that if you could manually run this thing. If I show you the model, if you understand the model, now you can run it manually because you know that, yeah, if they are under 30 years of age and they're not a student, they're not going to buy. So since we work in the fraud space, if exactly how you are making a decision to catch somebody as fraudulent, if you're gonna publicly announce that here is my model, and here is what I look for first, here is what I look for next, here's what I look for next, and then I decide whether it's a fraud or not. If that information is publicly available, eventually it will, then the fraudsters will know that as well. And say, oh, they are checking me on this, this, and this. Oh, I'll show them. They are far smarter, far more capable. They will never even get trapped. They will figure out a way to get trapped in the alternate. Oh, not a fraud. Let me see if I can squeeze in there somehow. So the trick is that you don't want to know or share with anyone what you're basing your decision on. And the model in the cloud from Google works perfectly for us. Because even I don't know, I give it a training set, it comes back, gives me a whole bunch of statistics that, yeah, we looked at this much data, it was this much sampling, we tested it on 10%, these were the results. It gives me a whole bunch of output, but it doesn't tell me what it found. It said, model is ready, this is the performance of that model. If you're happy with it, then start using it. If not, bring me more data, I will run it again. And that's how we kind of, if we don't know, our clients don't know, the fraudsters don't know, nobody knows. And then, of course, the unlimited scalability. So there is a question going on in the academic circles right now. Is the entire sampling theory now out the door? Do you really still need to sample data? You have the cloud, why? Run the whole thing through there. Why not? You've got 2,000 variables, you've got 800 variables, you've got 100 million records. The cloud can handle it. So why would you waste time trying to sample that data, which is what statistician will always start with. And there are theoretical reasons why they have to start there. But in data mining, you don't have such limitation. And then there are multiple algorithms that you can put to work. And whichever works better in a particular data set's case, that's what Google is going to put to work for you. So they've got all different kinds of great algorithms put together by their decision sciences team. And they apply all of them to your data, and whichever works the best, that's the one you get. So their Google decision sciences team is one of the top talents in the industry, and therefore we rely on Google for our fraud detection solutions. Questions? Remember, there is a book available to you, signed book, if you have a question.
What kind of Google service are you talking about?
There's a whole series of services. There's not just one simple thing. You have to spend time in there. Some are in beta, some are publicly available. We work closely within their team to figure this out. But these are Google services available that their YouTube uses that. Google News uses that. Their internal products also use the same services. They've opened those up for public. There is no branding that do this. There's like 20 different, some are available in our brochure, the ones that we're using, but geospatial analysis, there's localization, there's predictive API, there's a lot of stuff in there, BigQuery, that you can make use of depending on your situation. And it's not just Google. I mean, there are other services, similar services in the cloud also available. We just want to work with the best in the industry. Yes?
Google provides a similar service where you provide them the data, they do the modeling for you, but it's also helpful at times to know other people's data. When you use similar models, that will give you other insights. So do they also provide a service where they will look at similar data to yours, test the models, or give you more?
So the question is that sometimes your data may not be large enough, you may not have a representative enough sample of what you're trying to do, you've not been collecting history for too long, so can a service give you that insight, knowledge, and learning from others that you can leverage? I'm not aware of such a service at this time, but my view is that that's like the third step. Once you know what you're doing and how is your model performing and whether it's adequate or not, only then you start to look for the next tier. You will find it. Once you know exactly what you're looking for, somebody will be willing to work with you on their sampling or on their data. Yes? So the question is, can I describe the Google API? I really don't know. I mean, it's publicly available, so it's there, and my developers know how to kind of get to it and get it back. It is just like a service in the cloud. Like any other service in the cloud. I mean, weather.com has a service like that. You pass something, they send you back the temperature for whatever zip code you sent in. So Google APIs work the same way. Yes?
You may have mentioned it in some of your success stories.
In fraud detection, plenty. We've uncovered a whole bunch of activities going on that were not detected by the investigators because they didn't have the tools, and we got their data, ran through it, and we found a whole bunch of fraudulent activity very early. In the first step of our R&D, we started to uncover stuff that they could make use of.
Maybe the interesting thing on our application on the fraud side is that we really put in by the model. We take a bottoms-up and a top-down approach. So we found everything from individual transactions that are problematic. So, a procedure was added to a healthcare encounter that should have been added, to very top-down things, clusters, patterns, through link analysis, behaviors that link large groups of providers, employers, things like that. And then relationships between, say, unemployment insurance, which is one of the places where we work, between different claimants or beneficiaries, and between employers and employers, things that you just wouldn't be able to see without analyzing every single individual transaction. And that's really the power of the cloud. That's something we couldn't do before, because in some cases we're talking about hundreds of millions of transactions and records that we're crunching together and trying to find these relationships. So it's literally everything from tiny little, here's one little procedure to a group of podiatrists that are, I say podiatrists in air quotes because they're not really podiatrists, that are diagnosing schizophrenia and prescribing OxyContin, which is a rather unusual combination. But those of you that are in technology know that's how these things work. It's like trying to find a weakness in the system. Same thing when you're trying to hack a website or something. And they find, boy, that's one that it hasn't been covered, so we'll exploit it. And then once they do it once, it's all over friends. And they exploit it until that goal is closed, and then they go to the other one. So it's literally in the simplest individual transaction, you really do patterns and issues like that.
Google has toxic data.
I'm sorry.
Google has toxic data. And the clients send toxic Google.
The data stays with us. The data doesn't go to the Google Cloud, because a lot of this is healthcare, so we are very sensitive to privacy and regulations related to data. The cool thing about data mining is that if we mask it, the data mining doesn't care. It doesn't need the actual date of birth. We can just put a number in there. It doesn't need social security number. It doesn't need people's names and addresses. We convert them into geocode. So I mean, like, when the data goes to the cloud within the Google environment to churn and get value out of it, it's heavily masked from our standpoint as part of our working model.
Why take OxyContin? It doesn't go that long. There's no way of reverse engineering to get my address back out
Why don't you start buying a lot of Oxycodone, and we'll see if we can catch you or not.
Yeah, I understand that part, but you see, if you send lots of data about an individual geocode, it's very easy to reverse engineer that and give up a lot of privacy. If you send it to something big like Google, it's hard to sufficiently mask against them data mining all the stuff the government.
So stick to the, so the question is, because we do a lot of this data crunching, so a lot of this data is going into Google, so maybe somebody can figure it all out and they actually know who you are. So the way I would respond to that is that simplicity was the message here, right? So we don't do this massive all the data in one big chunk. We have broken it down. We have taken simple, smaller things at a time. We send them, they come back, we keep the results with us. We send the other one, comes back, we keep the results with us. So collectively, it's the task of our internal teams and our investigative domain knowledge to figure out what is actually going on, whether this looks suspicious or not. So it's not that there is this black box that you send all this data and they tell you what fraud is. No. We have specific things that we ask Google to do for us. There are specific things that we do on that data, and then we try to build the holistic collective picture and try to figure out how to detect fraud within that collective picture. Yes? I'm sorry? Oh, the book? Greg has a couple of copies remaining, I guess. So it's there with them. You can take a look at it. You can Google it. Google it. So you'll or Amazon it. You can pay right there to get it. So yes.
So for your company, you are trying to sell a service, or are you trying to sell us a product? So eventually, we ask for your help, to do some, data mining or do some analysis. So eventually, the data will sit on your site, and we just get the result, or you actually help us to build the product or the solution. Eventually, the state will own.
You want to take that one, John? The question is that do we have a service or a product? Do we come help them with their data, or do we take their data and then we kind of give them the output?
Okay. Yeah, so everything we do is software as a service, but we have specific applications on top of big data. So we're really not a big data company, we're a solution company. And what we do is, and Nauman made reference to this, our value is in bringing together data scientists, Google experts, and functional expertise. And we'll come in and say, in Medicaid, in SNAP, in insurance, in unemployment insurance, we want to build these models out, and we test these models with other states, with other customers, with other data sets. And there was a question earlier about, well, can we sort of compare my data with somebody else's? We kind of do that. We don't share data and compare data, but we build these models, and the models remain in their data list until we go to the customer, and then we take your data and tune it and then report. So that's really what we do. So we are not a software company. We don't put anything on premise. We bring our models, we bring our solutions, we take your historical data. We tune our models for your historical data, and then we deploy that through a dashboard into individual organizations. Does that answer your question on how it works? Yes. We get that a lot. I always get, are you a services company or are you a software company? And I always say neither. And in about 4 years, people are going to go, oh, I understand. But today, everybody kind of goes, well, you kind of got to be one or the other, but we're really not.
All right, looks like we're all set.
Fantastic.
Thank you.
Everybody.
Thank you.